Settle down, folks. It's time for our last lesson of the year. Let's go. Come on, get in place. Hello, everybody. Today is June 9th, and we are going to continue our discussion on making redox reactions useful. The last lesson focused on one type of electrochemical cell, and that is the voltaic or galvanic cell. Today, we are focusing on electrolytic cells. As a reminder, anodes are where the oxidation occurs. Red cathodes are where reduction occurs. Okay, so electrolytic cells force non-spontaneous reactions to occur. And in order to force those non-spontaneous reactions to occur, they must consume electricity. So electrolysis, the process occurring in electrolytic cells, means to break apart. Lysis means to break apart. There are many uses of electrolytic cells. For example, you could make sodium chloride. You could produce or refine metals. You can make jewelry. And you could even protect certain metals from corrosion. So a simplified view of electrolysis is shown here. This is going to be an example of molten salt. And what happens in this electrolysis is that you take sodium chloride and melt that down into liquid form, and that's going to be right here in this container. And through electrolysis, that compound is broken down into sodium and chlorine gas. Let's see how that works. Okay, so first of all, we have the anode where oxidation occurs. In electrolytic cells, the anode is positive. It is positive because like charges repel, and the positive sodium ions that will be generated during this reaction will be traveling away from that anode towards the cathode. And the cathode, therefore, is negative. These electrodes are inert. They are made of graphite. If you recall, graphite is carbon. The anode is always going to be losing electrons because of oxidation. So the electrons are going to travel in this direction and head towards that cathode. But as I just mentioned, this is a non-spontaneous reaction. We must have electricity consumed to force this reaction to occur. So this molten NaCl has sodium ions that are attracted to the negative cathode end and chlorine ions that are attracted to the positive anode end. During this process, that chlorine forms chlorine gas, and the sodium ions grab those electrons to form liquid form sodium atoms. So looking at the half reactions, we're going to have Na positive grabs an electron that's traveling down here to create sodium atoms. On this side, we have chlorine becoming chlorine gas plus 2 electrons. We need 2 chlorines to yield chlorine gas and 2 electrons. And therefore, we're going to have 2, 2, and 2 over here to balance that charge. When the sodium ions collide with this negative electrode, it picks up an electron to form sodium metal. Okay, let's look at another example of electrolysis. This is when we would want to take an object and coat the surface of that object with a desired metal. So I've got my little spoon here, and the spoon is acting as the cathode. It's the negative end. I also have a piece of solid silver. That's the anode, the positive anode. I want to coat this spoon with that silver and make that a very thin coating. It's electroplating. Now, the solution here, the electrolyte, can be a number of compounds. In this example, I'm using silver cyanide as an aqueous solution. So we have solid silver with a zero oxidation state, generating silver ions and electrons. This is a non-spontaneous reaction, so the battery is going to force this reaction to occur. The electricity is consumed. At the other end, here's our Ag positive ions, and they travel and they go over to that cathode, and they deposit on the cathode as solid silver. Why? Because these little electrons are traveling down to that cathode where the silver ions pick that up. So then we end up having silver ions plus that electron to make solid silver on the surface of that spoon. This is the reduction half. This is the oxidation half. To compare what we learned in yesterday's lesson to today's lesson, I've made this Venn diagram. So, Voltaic cells and electrolytic cells are both electrochemical cells. And electrochemical cells both use redox reactions. They both have oxidation occur at the anode. They both have reduction occur at the cathode. And they both have electrons flowing through a wire from the anode to the cathode. That's what they have in common. However, voltaic or galvanic cells involve spontaneous redox reactions, and the anode is a negative end and the cathode is a positive end in that cell. Whereas electrolytic cells involve non-spontaneous redox reactions, and the anode is positive and the cathode is negative in that cell. I'm excited to announce we have finished the curriculum for chemistry. Woo! Congratulations, folks. We're all excited here. Have a great day.